Number 28 is asking, what does A, B, C, these three changes do to the original equation after it's changed? So for here, when it's BrO3 minus is doubled, if we plug it back in, let's assume that this is x. So if it's doubled, it's going to be 2x. And if we plug it back in, so rate equals k times 2x times Br minus, and h plus to the second power, which is also equal to 2k, the concentration of x, and the concentration of Br minus, and then the concentration of h plus to the second power. And we can tell that this equation is doubled because the coefficient is 2, and this is taken out of the 2x. For b, when Br minus is halved, we can apply the same concept from A, which we assume that Br minus, the concentration, is x. And when it's halved, it goes to x over 2. When we plug it back in, which rate equals k times BrO3 minus, the concentration, which now is x over 2, and then h plus to the second power. So as you can see, if we take the 1/2 out, it's going to equal to 1/2 k BrO3 minus the concentration, and then the concentration of x, and then the concentration of h plus squared. If you look at this coefficient, it's 1/2. Doesn't change. If you look at these two problems, we can tell a general rule that when it's first order, no matter what the concentration of the substance is changing, it changes with the concentration. The rate changes with the concentration of the substance. Where if this is doubled, the rate is doubled. If this is tripled, the rate is also gonna triple. But if we come and look at C, now it's different because h plus is the second power in the equation. So now we do it again. Let's assume h plus equals to x. And the quadrupled would be 4x. Now if we plug it back in, rate equals k times BrO3 minus times Br minus times h plus to the second power. Well, now this goes to 4x. So the rate would be k times BrO3 minus, of course, Br minus, and then 4x squared. And now if we look at it, 4 squared would be 16. So the rate would again be 16k if we take the 16 out of here. BrO3 minus times Br minus, then times x to the squared, which is the same because now x is h plus. This is also equal to h plus second power to the second power. And so that means it's the second order. As you can tell, the coefficient here is 16, which determines that after it quadrupled, the entire rate is multiplied by 16.